Hi everyone. Whoops, sorry about that. Today we are looking at the law of sines and law of cosines, which I realize sounds very similar to what we've been doing. We've been working with sine, we've been working with cosine, okay? But the laws specifically are different formulas that have to do with sine and cosine, but it's not like SOHCAHTOA, okay? And it's derived from SOHCAHTOA. And the reason these things are important is our two laws allow us to do some trig stuff with non-right triangles. Okay, so everything we've done so far with SOHCAHTOA, with sine, with cosine, has always dealt with triangles that have right angles in them. Now our laws allow us to apply these new formulas to any triangle I want anytime. So we're going to start with the law of sines. And the law of sines is pretty simple. It's a proportion. And it says the sine of an angle over the side is equal to the sine of another angle over the side. And I guess I should be more specific about that. In a triangle, and I don't know that I've ever come right out and pointed this out before, but in a triangle, we use capital letters to represent the angles. So notice how I put capital letters at all the corners, meaning this is angle A, this is angle B, and so on. And we could call this side, for example, side BC. But in geometry, we also had a way where we could just like name this side with a single letter. For that, if we're going to use a letter to represent this side, we want to use lowercase letters to kind of differentiate from these. And we also always use the lowercase letter from the angle that's right across from it. So for example, if this is angle A, then this side over here would be called side A. If this is angle B, then this side down here would be side B, and then angle C goes with side C. So in my formula over here, whoops, missed an arrow here, specifically when I say sine of A over A and sine of B over B, that's talking about an angle and a side that are directly across from each other. It always has to be a pair. It always has to be an angle and a side that are across from each other for this to work. And I'm not going to go into the proof right now, but again, the proof of this statement, the reason this works, we can use regular SOHCAHTOA. So our right triangle trig came first, and then we learned this stuff, and then we found out this stuff, okay? So when you're doing law of sines, the first thing I always look for is one complete pair where you have both the angle measure and the side length. And so what I mean by that is like right here, I have an angle measure and a side length that's right across from it. Okay, so I can set that up in fraction form by saying sine of the angle over the side length, which is 7, equals, and then I'm looking for side AB, which is this right here. I'm going to just call this X, all right? And that's across from this 53. So I'm going to say sine 53 over my side length X. And then it's just a matter of cross multiplying to solve for X. So when I cross multiply here, I'm going to end up with 7 times sine 53. Notice I'm not putting anything in my calculator until probably the very end. That way I don't have to write down any decimals or anything. Equals, and then cross multiply here, x times sine 44. Okay? And then I would divide by the sine 44 because I'm trying to get x by itself. And I'm going to put all of this into my calculator at one time. I'm just going to make sure that I'm careful about closing parentheses when I need to. Okay, so what that's going to look like, let me get rid of all that junk. 7 times sine of 53, close your parentheses, divided by sine 44, close your parentheses. Okay, and I get 8.04. I just want to double check I thought of this as I was typing it in. Yep, I am in degrees, so just want to make sure that was correct. Looked correct, but Okay, so that means that my side length over here would be 8.04, and that seems pretty reasonable looking at the size of this triangle. So x equals 8 point, I guess it would technically be 8.05. Okay, so that's how law of sines works. One more example involving law of sines, and I have to warn you that there's actually a little complication that happens in this specific scenario in example 2, and we haven't quite gotten to the point where we're ready to talk about that yet, but we'll circle back to it. So just so you know, this isn't quite as simple as it looks, but for now we're just going to kind of take it at face value. Okay, so again, in order to know that I'm allowed to use law of sines, I have to have an angle and a side length across from each other where I know both of the values. Okay, that's how you're going to be able to tell in a minute which law to use. And so here I'm going to set up sine 97 over 22. Okay. Now, I'm trying to find the measure of angle C. So now it's like this is my x. This is my thing I don't know. And that is across from the 19. When I set up my other fraction, remember this is your angle measure, right? So we're going to say sine of x over the side length, which is 19. Okay, so just like before, I'm going to cross multiply. So I'm going to go 19 times sine 97 equals, cross multiply here, 22 times sine x. Okay. Trying to get x by itself, so let's divide by the 22. And now this is going into my calculator. Okay, so 19 sine 97, close that parenthesis, divided by 22. That's kind of a weird answer. So I get 0.8572. Well, that doesn't make much sense as an angle measurement. What you have to remember, though, is that that's actually equal to sine of x. It's not just x this time. That's equal to sine of x. And so now we have to think about, how do we figure out what x is? Well, if it's an angle measure I'm looking for, I can use the inverse sine. So in my calculator, I can hit second sine. And then if I just want to pull that same decimal down, I can go second, and then ANS is up here on the negative key. Okay, and that ANS means pull the number up from right before the previous step. So inverse sine of that number, and I get 59 degrees. So as soon as you know that you're looking for an angle measurement, you know that at some point in your process, and that's going to be true even when we do law of cosines, some point in your process you're going to end up having to use an inverse, okay, because inverses are used to find angle measurements. Okay? All right, let's move on to law of cosines then. Okay? Law of cosines. Law of cosines looks a little bit more complicated. With law of cosines, if you look this up in your textbook, it actually gives you like 3 different formulas to use, depending on which side you're looking for. Here's what I boil it down to. I always use this version. A squared equals b squared plus c squared minus 2bc cosine angle A. And again, keeping in mind that side A and angle A will be right across from each other. Okay, these ones, the lowercase letters, are all side lengths, and then this one represents an angle measure. And so what I do is, if I'm looking for a side length, I label that side A, and then that automatically makes the angle across from it angle A. Or if I'm looking for an angle measurement, I label that angle A, and then the side across from it would become side A. Okay, and then B and C are just the other 2 side lengths, and you should always have those given to you. What that does mean sometimes is that you sometimes have to ignore the letters that they give you on the triangle and put your own letters on. Okay, and I'll show you that in this very first example. So the length of side AB, that's this side right here, okay? I want to call that side A. So whatever I'm trying to find, whatever piece I'm trying to look for, label it A. Whether it's a side or an angle, label it A. But if this is side A, then that means that technically this 41 degrees should be my angle A. So notice I'm ignoring the letters that were given to me on the picture. Okay, they are meaningless. I want to letter it my own way. And sometimes I don't even give you letters. So then you don't have to worry about it. But just ignore the letters that are given to you and put the letters on the way you want it to be. And then B and C are just the other two sides, and it actually does not matter which is which. Okay, I could have done these the other way around too. So now if I go to fill this into the formula, A squared, I don't know what A is, so I'm going to leave this as A squared, equals B squared plus C squared minus 2 times B, which is 29, times C, which is 13, times cosine of angle A, which if this is side A, then angle A is 41. Okay, so that's what my formula looks like. And I know that looks complicated, but here's what I like about this. All of this can go straight into your calculator. Okay, so anytime you're using law of cosines to look for a side length, you're going to be able to go straight to your calculator. Let me start us with a clean screen here. And I'm just going to type in 29 squared plus 13 squared minus 2 times 29 times 13 times cosine 41. And I get 440.9. Okay, does that mean that my side length here is 440.9? I hope your answer is no. Okay, here's the issue, and I'm just going to write down 0.95. This is equal to A squared. So if I want the side length A, I need to take a square root of that. Okay, and so side A would then be the square root of previous number, 20.99. I'd probably feel safe just rounding that up to 21. Okay, so my side length now is 21. And that seems reasonable looking at the other side lengths in the triangle. Okay, so when you're looking for a side length law of cosines, even though it looks harder, actually it's just plugging a bunch of numbers into the calculator, okay, and just remembering to take a square root at the end. Okay, this next one, example 4, where you're looking for an angle measure. This is probably, of the 4 examples we're doing today, this is probably the most complex one, and you'll see why in just a minute. So first of all, find the measure of angle A. And by the way, we didn't really talk about how do you know when to use law of sines, when to use law of cosines, okay? Remember when we did law of sines, I said that you always have to have an angle and a side length paired up. So back in this previous example, there was nowhere, like I have this angle, but I don't know this side. And then I have these two sides, but I don't know either of the angles that goes along with them. So I couldn't have used law of sines. And that's what tells me that I have to use law of cosines. Okay, I usually start with law of sines in my mind. And in this one, I don't have any of the 3 angle measurements. So I'm not going to be able to use law of sines because, again, I need to have that complete pair to be able to start law of sines. Okay, so now that I've decided I'm using law of cosines, looking for angle A, which I would label A even if they didn't have an A there for me, even if it was a different angle, I would label that angle A, which means the 10 over here is side A, okay? And then the other 2 sides are B and C, and it really doesn't matter which is which, although since these letters are here for you, I just stuck with those, okay? So this time when I plug into my formula, which is up above, hopefully you have that written down, so I don't want to scroll back to it right now, I'm going to start with lowercase a squared, and I do know that number this time. So I have 10 squared equals, and then b squared plus c squared. So 17 squared plus 11 squared minus 2 times b times c times cosine of angle A. And I don't know what angle A is. This time, you cannot go straight to your calculator. I mean, we're going to use our calculator, but we can't just type all of this in. And here's why. Let me just do kind of a simpler example off to the side here. If I gave you the problem 12 equals 10 plus 4 times x, okay? Can you add together the 10 and the 4? I hope that you're all saying no, because this 4 is attached to the x with multiplication. So I can't combine it with the 10 because the multiplication has to come first, right? And that means that over here, all of this, the 2 and the 17 and the 11, is all stuck to that cosine of A through multiplication. So I can do this math if I want to. I can multiply those together, but I can't combine it with these, okay? Because this is all multiplication, this is all addition. So I can put these together, I can put these together, but I can't combine these two. There's like a giant wall here between those two sets of numbers. And then also with this equal sign here, I can go ahead and do the 10 squared, but I can't combine it with anything over here unless I start moving things to the other side, which is exactly what I'm going to do. So these three things that are circled, I strongly recommend you circle them on your paper too, because when you're doing this process, you're going to do them in chunks. You're going to do them in these three pieces. So 10 squared is 100. 17 squared plus 11 squared comes out to be 410 minus, and then here I can do 2 times 17 times 11 and get 374 cosine A. Now remember, still make sure that you don't fall for the trap here. We simplified this, and I have some people every year who are good at that, but then they still go ahead and subtract these numbers. If we were going to subtract these, we would have done it back here, okay? This 374 is still glued to that cosine of A, okay? So what I'm going to do instead is I'm going to come along and start moving things from one side of the equation to the other. I'm going to subtract this 410, which, by the way, is the same thing you would do here, right? You would have started this by doing minus 10, okay? So subtract the 410, and now I get, let's see, I believe that's negative 310, but I always mix up negatives, yeah. Negative 310 equals, don't lose that negative sign, that's negative 374 times cosine A. And then, because this is multiplication, now I can get rid of that negative 374 by dividing. And divide here. Okay, I know I'm getting low here on the paper. So I'm going to divide negative 310 divided by negative 374. And I get this decimal, okay, 0.8289. And that's to be expected because this is now equal to cosine of A over here on the right. And then I'm going to do the inverse. I'm going to do inverse cosine of that decimal, 0.8289, because I'm looking for an angle measure. So in my calculator, inverse cosine, second answer, and I end up with 34 degrees. And that would be my angle A up here, okay, which makes sense. So when you're looking for an angle measure with law of cosines, when you've got the variable over here kind of buried in the mess, you can't just plow through on your calculator. You've got to do it in chunks and subtract, and then do this chunk and divide to move it out of the way, okay? And then you get down to cosine of A equals some decimal, do an inverse, and then you'll have your answer, okay? Okay, so that's it for today. I believe you have some lesson masters to work on after this lesson, so we're going to give those a try. And then we will circle back to this stuff and review it along with some unit circle stuff over the next couple of days.